Okay, this problem is involving an elevator. An elevator is in an elevator shaft like this, and unfortunately it's falling. It's going down, and the elevator's mass is 750 kilos, and it's going to fall 25 meters. Okay, so let's extend this a bit, and at the bottom of that 25 meters is a big spring. Okay. The question is, A, calculate the work done by gravity on the elevator before it hits the spring. So A is the work done by gravity. B, calculate the speed of the elevator just before hitting the spring. V final of elevator at this location, just before hitting the spring. And then C, the amount that the spring compresses. So let's say X equals question mark, where X is this distance here that the spring is going to be compressed, maximum compression. Okay? The way we'll do this is it's quite easy. Work is equal to force, so times distance. Now in this case it's the force of gravity times the distance that it falls. So that's just going to be, let's go back over here and let's try and make some room here. So we'll say A, work equals force times distance. The force of gravity is mg, and the distance is d, that it falls, which is 25 meters. You can also use the variable h. So that's 750 kilos times 9.8 newtons per kilogram multiplied by a d of 25 meters. Now, just a note here, which way is the direction of the force? It's down. And which direction did the elevator, delta D, which direction did it travel? Down as well. So you see, both FG and D were both down, so they're both in the same direction. So that means it's positive work done. If by chance in another question you have a problem where the force is in one direction but the distance traveled is in the other direction, which is definitely possible, in those types of situations that would be negative work, but not in this case. Okay, so what do we get here? 750, enter, 9.8 times 25 times. Okay, we're getting 183 point 8 or so times 10 to the power of 3 joules of work done by gravity. Now, question B says, how fast was it going? In order to do this question, of course this is an energy problem, so we have to use energy. Okay, so at the top, all we have is mgh, which is gravitational potential energy. We don't have any kinetic energy at the top, and no other energy. And then at the bottom, there we can say that this location here, let's change colors. Let's say this location here is 0, so that there is no gravitational potential energy at that location, so we would only have kinetic energy. So we'd have 1/2 mv squared. And of course the spring isn't yet compressed at location 0, so therefore there's no elastic potential energy either. Let's cancel out the m's and solve for v, and we get 2gh square root equals v. And so that's going to equal 2 times 9.8 meters per second squared times a distance of 25 meters. And that's going to give me 2 enter 9.8 times 25 times, and then take the square root, which is equal to 22.1 meters per second. Now, if we now we're now on part 3. So let's take a look. Part 3 says, find the distance that it gets squished. Okay, now in order to do this, what we have to do is say to ourselves, let's draw this picture again, okay? Let's draw it in the compressed state. So here is 0, okay? And here is the elevator, and it has now gone down to this location here. This distance, let's say it's x. And of course, if we say initial energy equals final energy in this problem, then initially at this location here, it doesn't have any gravitational potential energy because it's at 0. It does have kinetic energy, 1/2 mv squared. And remember, this v here is that, okay? And also, we have no initial elastic potential energy either. Now, finally, at this location, so this is our initial position, this is our final position. Finally, obviously the velocity at our final location is 0, so we don't have any kinetic, but we do have gravitational potential energy, mgh, plus elastic potential energy of 1/2 kx squared. Now, what are we looking for? We're looking for x. Okay, so the way we would do this is we would say, and by the way, I've written h here, but understand that in fact that's going to be replaced in a moment. Let's write the equation again. 1/2 mv squared equals mg. Now what is the h? Well, the h is actually negative x. Because you see, this way is positive, right? Going up is positive, so this way is negative. So if that's 0 here, then going down, x would be a height of negative x. And we add now 1/2 k. And by the way, I'm not sure if I gave you this in the initial part of the question, but the k value of this spring was given in the question as being 40,000 newtons per meter. So now we can say, what's x? X is negative x squared, okay? Because we've said that's x. So if we now solve for x, now as soon as I look at this equation here, I'm going to recognize that in fact it is a quadratic. I'm going to rewrite it now, putting the square term first. 1/2 k, and negative x squared is simply going to be x squared. It doesn't matter if you square a negative value, it's going to be positive. Plus, and I know I'm writing plus here, but in fact I'm going to write negative mgx. That's that term there. and then negative plus also a negative 1/2 mv squared. Why? Because it's on the this term is on the left hand side. You bring it to the right hand side, it's going to be negative. Now, if you'll notice here, this is actually a quadratic, and if I change colors here, this is the a term. This is the b term, and this whole thing is the c term. So a, b, c, and the equation, of course, is of the form ax squared plus bx plus c equals 0. Now you can use the quadratic equation to solve this, i.e. Negative b plus or minus the square root of b squared, minus 4ac divided by 2a. However, fortunately, I have a calculator. Let's calculate the values for them. A is equal to 1/2 k being 40,000 times, and that's that. B, so that's just 20,000. B is negative mg, m being 750, and g 9.8, and c is equal to negative 1/2 750 times v. Now what v was that? That was this v here is the v we're talking about, and that, of course, as I've pointed out here, was the 22.1. So let's put that in. So what do I get for these guys? So 750, enter 9.8 times, and that's going to give me negative 7,350. And this one is 0.5, enter 750 times 22.1 times, and I've got 8,287.5. I'll have to continue this video, so there will be a part 2.